Hello, I'm Giaccai, and today I'm going to talk to you about identifying different types of Sumi using Raman Spectroscopy. So just to start us all off on the same page, let's first talk about Sumi. Sumi is often referred to as Chinese ink, but it is used throughout East Asia. It is most often found in the form of ink sticks. You can see an ink stick right up here. And forming Sumi into ink sticks is advantageous because the ink sticks are much more resistant to spoiling, they're easily portable, they can even be considered art forms in their own right with very decorative forms, which will make them valuable as a gift. In the painting and calligraphy communities, different qualities of ink are attributed to the use of different soot types. Here's actually an example of one of those decorative ink sticks that I mentioned from our museum collection, and let's talk a little bit now about how Sumi is manufactured in general. So Sumi is made from an animal skin glue that is heated until it's liquid and then mixed with soot. Small amounts of camphor, musk, gold, and up to tens of other ingredients can be added at this stage. The mixture is beaten and kneaded together, depending on the various manuals, anywhere from between 20,000 to 30,000 times. There's been lots of books written on ink and ink sticks. It just has such an important role in East Asian society, and they give us, if you can read Chinese or Japanese, they can give you a lot of information about what's going on with the manufacture of ink sticks. That's why we get such a large range of numbers here based on what different people were saying was going on. This illustration here was originally from a Sung Dynasty manual, and it shows the initial stages of mixing the ink through the beating of it down here and kneading and forming into ink sticks. And you can see that even in modern day China and Japan, sometimes this kneading is done via hammer and anvil, although these days the anvil itself can be heated, which helps keep the glue malleable. We also will sometimes use a rolling mill, and here you can see the steam rising off that warm ink mass. One communication that we have from a Chinese workshop discussed adding 27 additional ingredients into their award-winning ink sticks. However, the vast majority of Sumi, probably 99% of an ink stick, will be composed of just that soot and glue mixture. Everything else is really very present in very small amounts. Ink stick molds are used to form the ink stick and impress those beautiful designs on the ink sticks here. That warm mixture of ink is rolled into a cylinder, pressed into the mold, and allowed to cool. And after they're cooled, the ink sticks are removed from the mold and then dried for anywhere between 6 months to 2 years. Depending on the manufacturer, ink sticks can still be dried in the traditional way. You can see over here that this is pretty much exactly the same way that they were hanging ink sticks back in the Sung Dynasty manual illustration. They could also just be laid out in trays where they're regularly flipped in order to maintain an even drying. Now I'd like to discuss a little bit more the different types of soot that are used in ink sticks. So I'm going to start, we're going to go backwards actually. I'm going to start with commercial carbon black, which first came about in the late 19th century and is still in heavy production today. Carbon black today is used to strengthen rubber in tires. That's what makes our tires black, and is the black pigment in many commercial inks and printer toners. Carbon black is formed from the burning of mineral oils and hydrocarbon gases, and inks made from carbon black are thought to have a purplish tone to them. Although we would not expect to find carbon black used in an older work of art, it is possible that carbon black could be found in a 20th century ink stick. The next of the two primary soots that are used in East Asian inks, carbon black not being one of those, is generally referred to as lamp black in English. So lamp black is can be used interchangeably with carbon black, but in this talk I'm going to specifically refer to soots that are made by the burning of animal fats or vegetable oils as lamp black. So often lamp black is thought of as lending a brownish tinge and a shiny attribute to the ink that's made with it. Traditionally this soot is collected in an upside down bowl, and here you can see a picture from a late 14th century book on soot that shows these upside down bowls here covering oil lamps and collecting the soot in them in this back room. So over the 600 years or so since it was first discussed, the method of making lampblack has really, the traditional method has changed very little. This is the shadow of an upturned bowl placed over an oil lamp here. This separation between the flame and the bowl is maybe 10 centimeters. And this bowl is rotated every 20 minutes or so over the course of a few hours before the bowl is completely removed, the soot brushed out, and then the bowl is replaced and the process starts again. The wick size inside the bowl can vary, and the fuel source can vary quite a lot. Although a variety of different oils have been used over history. In Japan these days, mostly canola or rapeseed oil is used, whereas in China, tung oil and pig fat mixtures are used most frequently. In some larger workshops in China, the lampblack method has been updated to have a long, continuous row of wicks that's fed with that same fuel source that's used in the traditional method today. The soot is still collected at about the same distance from the flame as in the traditional method. However, the soot collection drum is a steel drum that's constantly rotating over the flame just to continuously collect the soot as soon as it's formed. Pine soot is the oldest soot thought to be used for making sumi. It was first mentioned in the Warring States period in China. And just to talk about, again, how much of a role ink has in the cultures, they were talking about having famous ink makers that go down in history starting as far back as the Wei Dynasty in China. So pine soot can be made and collected using a variety of different methods. This is an example of one where you have a pine fire made in the lowest chamber of a stack of pots that can be up to 5 chambers high, and the soot is graded based on its distance from the fire. The topmost pot, or the uppermost pot, is thought to have the highest quality ink that's used for painters or calligraphers, whereas printing ink would have come from a more middle pot region. Pine soot inks are thought to have a bluish tinge. The pine soot can be made from pine branches or roots that are then aged before burning. Here you can see the illustration of making, from chopping down the pine trees to building the soot manufacturing facility, where you have the fire here, these chimneys covered over, and the collection of the soot in these distant tents, for lack of a better word. Whereas in this Ming Dynasty illustration of pine soot manufacturing, you can see the flame at one end of a long chimney, and after the pine soot fire is quenched, the chimney can be deconstructed and the soot collected. Finest quality soot, again, comes from the furthest area of the flame. Soot for printing inks comes from the middle regions, and then the regions closest to the flame would be reserved for things like painting buildings, something low quality. One interesting thing about the same book that has this print in it from 1637 claimed that 90% of ink that was made at that point in time in the Ming Dynasty was made from pine soot. And here's just a few modern facilities using pine soot. And again, we have a similar method where we have the pine soot flame, a long chimney. In this case, the chimney is mostly buried or you can't see it because of the soot collection room that's above it, but it has quite a long chimney. Here that chimney is out in the open with one big room that's collecting all of the pine soot that's being made. And I don't want to go into a super in-depth explanation of soot formation, but just to emphasize that here, the final stage of soot, the fractal aggregate, has millions of carbon atoms in it and is quite complex structure. There are scientific techniques that can analyze sort of all of the different stages along here and look at different parts of the soot fractal aggregate. The method that I'm going to be talking about, Raman Spectroscopy, studies this zone here, where we're changing between chemical growth and particle inception. So now on to the more scientific portion of this talk. My study here used soots that were collected from 10 different workshops in China and Japan. Some workshops made both soot and inks, others made only inks or only soot, but in total we were able to collect 20 different soot samples. I categorized those into 4 different soot types, and we collected 9 ink sticks from the different manufacturers. Our goals for this project were twofold. We wanted to know, could we differentiate between pine soot or lamp black? We know we have these different qualities associated with pine soot based inks versus lamp black based inks. Is that something that we could actually identify on a work of art? And we also wanted to know if we could differentiate between inks on a work of art. For example, if we have the black from the key block here, which is used for the outline and forms the backbone of the print. Whereas on this particular page, we also have an overlay of rich black that occurs at the nodes where the bamboo leaves meet the bamboo stems, and we have these pale gray leaves. Would we be able to tell if there were different inks used for those 3 different printing steps on this work of art? And the technique that we're using is called Raman Spectroscopy. It identifies the molecules in the larger soot fractal aggregate, and one of its big advantages is it can be undertaken directly on a work of art. We don't need to take a sample. It's a generally pretty small spot size, and it does use laser excitation in order to get the information from the work of art. However, we found that with appropriate care, no damage is done to the sample. Or work of art, whatever's being analyzed. That generally involves using a very low laser power and just continuous monitoring of the situation. So here's a few examples of Raman spectra from other carbon-based black pigments. Here you can see we've got charcoal and graphite pencil, and they are visibly different from India ink, which is made from soot as well, so is very similar to Sumi. Graphite has these sharp, narrow peaks, while charcoal has this visible shoulder in this region. But as soon as we add in 2 other types of Sumi, one from Korea, one from Taiwan, you can see that all of the soot-based inks have a very similar spectra, and it would be difficult to differentiate between them just at a quick glance. So we then went another step further. Now each of those Raman spectra of soot has 2 peaks. The G peak here, from how graphite-like a sample is, and the D peak here, which arises from how differences between graphite and soot. So if we fit the 2 peaks, we can determine the peak width, the peak location, so exactly what Raman shift the peak has, and the peak heights. And we then decided to use various statistical analyses to highlight differences between the different soot and ink samples that we were examining. So when we measure the D and G peak positions, we found that they vary dependent upon the wavelength of the laser we used in the Raman instrument. This is a phenomenon called peak dispersion. So the D band, this one here, shows the same peak dispersion for all of the soots regardless of soot type. Whereas in the G band, the peak dispersion varies by soot type. Most of the traditional lamp blacks, which are in yellow, showed little or no G band dispersion, while most of the pine soots in red had a more typical G band dispersion that you would expect for a soot. So from this, we were able to conclude that traditional lamp blacks had a more graphite-like structure than pine soots, because graphite is generally shown to have little to no G-band dispersion as well. We also examined 4 woodblock printed copies of a text called Kaishian Gaden. Originally it was a Chinese text, and when it moved to Japan, it became one of the first color printed books in Edo, Japan. Freer and Sackler has parts of 4 different copies, all of which were published in Kyoto, but were thought to be published by 2 different publishers. We used a statistical technique called Principal Component Analysis, or PCA, to analyze our data. PCA takes information from the 5 different peak fit variables, the peak width, the peak location, and the peak height ratio, and it transforms it using an algebraic method by a computer, so we don't have to do any of it ourselves, and it transforms it into these new axes called principal components. So here we have principal component 2 versus principal component 3, and we've colored each of these dots based on the publisher of the book. These 2 ovals show how likely, with 95% certainty, a dot is likely to be published by either of the 2 publishers. And you can see there's a significant amount of overlap between these 2 confidence intervals. So although there is some separation between the 2 publishers, there's not enough separation for us to be confident that we can distinguish between the 2 publishers using only the Raman of the black ink. However, we also did one more sort of thing that we were interested in, and we looked at a specific page in one copy of the book. This is the one that I talked about earlier, where in this bamboo print we had the key block, the gray, and the sort of rich black overlay, all on that one page. Unfortunately, we were not able to get any Raman spectrum from the gray. There just isn't enough Sumi present to get a good Raman spectrum from it to allow analyses, but we were able to get a number of Raman spectra from the key block and from the overlay. And when we analyzed those with principal component analysis, we were able to separate quite distinctively the samples from the key block versus the samples from the overlay, which suggests to us that this publisher used different ink, maybe a higher quality ink, but certainly a different ink to make those beautiful rich highlights there occurring at the nodes of the bamboo leaves. So if we look back to our goals, can we identify the difference between pine soot and lamp black? Yes, we think we have a method forward for going forward for that. Can we differentiate between 2 different inks on an artwork? Maybe. We were able to separate the inks from the key block versus the rich details here, but unfortunately the pale grays just didn't contain enough ink for us to get information about using Raman spectroscopy. So overall, we think that this technique shows great promise in examination of Sumi. Now, as with most projects, this did not happen in a vacuum. I really have many people to thank for their help in this project. It's truly been a group effort in acquiring samples, borrowing instrumentation, and just helpful discussion about various points and stages in this project. And lastly, I'd just like to say that if you have any questions or want to further this discussion at all, please feel free to contact me by email. I would love to talk about it further.